Good day, Cretans. So in this video, we'll be looking at the quadratic function or the parabolic graph. So in the previous video, if you remember, we did the straight line graph. So now we are doing the quadratic function or the parabolic graph. So the parabolic graph has this formula that says y is equals to ax squared plus q, where a cannot be 0. So we are going to deal now with this type of graphs, which are called parabolic graphs. So let's first explain these variables. So the first variable that you see here is a. That variable a, it determines the shape of the graph. That constant, this is normally a constant. For example, you can have an equation like y is equals to 2x squared plus 4, for example. Or you can have an equation y is equals to negative 3x squared minus 8. Just making an example. So if you see this coefficient in front of this x being positive, if the coefficient is positive, that means that a positive coefficient, it means that your graph will be positive. In other words, you are going to have a parabola with a positive shape. In other words, it's like a smile. So imagine that there is a smiling face there if the coefficient or a is positive. But if this coefficient or a is negative, that means that the shape of the graph now is going to be negative. So imagine that you have a sad face there if the coefficient a is negative. That's why they said here, if a is a negative value, then the shape of the graph will be a sad face, or will be negative, or it will be pointing downwards. But if a is positive, your parabolic graph will be pointing upwards. So that's the first thing that we have to know, that a is there, determines the shape of the graph. Then the q here, the q is the y-intercept. So this q is the y-intercept. It actually tells us that the graph can be lifted up or it can be pulled down. For example, look at the q here. The q is a positive 4. That means this graph was lifted up 4 units. But look at this q here, it's a negative 8. That means this graph was pulled downwards or shifted downwards 8 units. Because on the Cartesian plane, let me draw a Cartesian plane here. So you can see now for the first graph, let's say that I was drawing now that first graph, y is equal to 2x squared plus 4. You can see that first my a is positive, so that means that the shape of the graph is facing, is a smiling face, it is pointing upwards. And you can see now this graph was shifted or lifted from 0 up to 4. In other words, it was lifted up 4 units. That's what that q represents. It means that it is lifted upward if the q is positive. But if the q is negative, that means that it was shifted downwards. For example, look at this second graph, second equation. If you look at this parabola here, it means that number 1, a is negative, so that means that it is a sad face. Number 2, it is shifted downwards because of the q here is negative. Let me give you an example. Yeah, you can look at this one. You can see that a is negative, so the graph is pointing downwards, and check now, it is shifted from 0 up to negative 8. So it has been shifted downwards 8 units. So this is the kind of a graphs that we are going to be dealing with. We call these ones the parabolic graphs or the quadratic function. So I'm going to do like 4 examples here. So I'll do 2 examples where you are given the graph and they said determine the equation Then I'll do two examples where you are given the equation, they say draw the graph. So this is what we are going to be dealing with. So this is example number 1. Okay, so for example number 1, you are given here, so we say this is example number 1. So in this example, you are given the turning point, or you are given Q. Remember, we said now that point is Q. It represents the number of units upon which the graph was lifted. You can see this one, it was lifted positive 4 units. In other words, it was lifted up from 0 to 4. So we can see that here Q is positive. The y-intercept is positive 4. Now, they gave us a point on the graph. So this is a point on the graph. So when you are given the turning point, so I'll say that Q is the turning point. That's the first thing they gave you. The second thing, they gave you a point on the graph. So they gave you a turning point and they gave you a point on the graph. So when you are given these two things, this is the method now that you are going to use to determine the equation of this parabolic graph. So you have to write that formula that says y is equals to ax squared plus q. So this is the equation, this is the formula, or this is a standard form. So you need to find y, you need to find a, you need to find x, you need to find q. All these variables now must be given concepts. In fact, y will be the standard, the subject of the formula, so you don't have to find y, but you have to find a, x, and q. So it's easy to find y and x because these are the 2 points that you are given. Remember, they gave you a point, so you're going to use this point that they gave you. The point they gave you is -2 and -8. Remember, this is a x coordinate, this is the y coordinate. So you can substitute now these 2 points. You can take the y, which is -8, and substitute it under y equals to a. We don't know a at the moment. You can take this -2 and substitute it in place of x, and then you can say squared plus, what is q? Q is given, the turning point is 4 units. So you can put that positive 4 there. So we do have y, we do have x, we do have a q. This is what we're given. They gave us a turning point. The turning point we said is q. They gave us a point on the graph. The point on the graph is x and y. So you can substitute all these 3 variables, the y, the x, and the q. Then you must go and find, a. So now we're going to say, okay, we have -8 equals to -2, you square it, it's going to be a positive 4. So we're going to say plus 4. So let's take that 4 to the other side. So we have -8 minus 4 equals to a times 4, that is 4a. So we have this equation now. So we have to add now these two like terms, -8 and -4. That's going to give us a -12, which is equals to 4a. So we have to divide now by 4 on the right, divide by 4 on the left. So we know now a is equals to negative, what is 12 divided by 4? It's 4a 12, that is a -3. So a is equals to -3. Now let's go back now to our equation and substitute for a. So we're going to say the equation is y is equals to -a x squared plus 4. So this is the equation of the parabola. Is y is equals to -3x squared plus 4. Yeah, I think my screen is a little bit freezing, so the words will be showing later on. But yeah, sorry for that. So this is the equation now. Y is equals to -3x squared plus 4. So we went to find a, and then we substituted for a here. Then this is the quadratic equation. So you look at it, the a is negative. Yes, the a is negative. That's why we have a sad face. Look at our parabola. It's a sad face. It was lifted up 4 times. Yes, it was lifted up 4 times. So this equation is accurate. It represents the graph perfectly. So yeah, this is the equation that we're required to determine. So it's just this method, just simple method that you have to use to find this equation. You just have to substitute the turning point and substitute for Q. Then you find A. After finding A, then you substitute back to your equation. So this was example number 1. Now let me go and do example number 2 and see now another way they will ask you to determine the equation of the parabola. Okay, so this is example number 2. So let's look at example number 2. They said determine the equation of this graph. Now let's check what we are given here. In this one, you are given the root and the other root. This is the negative x root. This is a positive x root. And they gave us a point on the graph. But you can see that now the turning point is not given. They did not give us the Q. Here, these are the two things that we are given. They gave us the roots of x. Number 2, they gave us the point on the graph. So these are the two things they gave us. Yeah, in the previous example, they gave us the turning point, which is Q, and the point on the graph. They did not give us the roots. But here they gave us the roots, then they gave us a point on the graph. So the method that we are going to use now to determine the equation of this graph will be a little bit different from the one we used previous. So for this one, we'll use this equation now. Y is equals to a bracket x minus x1. So we're going to use this one, a minus, okay, let me put this x1 in a different color because there's something I want to show you here. Then I'm going to say bracket x minus x2. Yeah, so this is the formula now that we are going to use to find the equation of this graph. For the previous question, we used this form, y is equals to ax squared plus q. Yeah, but in the current example now, we don't use this formula. We use this one for example 1. So for this now particular example, we have to use this method. In other words, there are two formulas that you have to know. The first one, you use it when you are given the turning point and the point on the graph. The second equation, you use it when you are given the point on the graph and the two roots of x. These are the only two formulas that you have to use in this particular section of this topic for the parabolic equation. So now, how to apply this formula now to determine the equation of the graph? So you know A is the shape of the graph. You already see that the graph is a smiling shape, so that means that A is going to be positive. Now this blue x and this blue x, it represents now your roots. So in other words, x1 will be represented by this negative 4. So this will be a negative x1. This x2 will be represented now by this second root, which is 4. So I'm going to substitute these two roots here, x1 and x2. So I have y is equals to a bracket x minus, the first root we said is negative 4. So I'm going to put negative 4 here. Then I'm opening another bracket. I said x minus, the second root now is positive 4. So I'll put positive 4 on the second root. Now I have to now calculate this. I have y is equals to a x. Negative times a negative, that's going to be a positive bracket x minus a 4. I can calculate this I can factorize this. So you said y is equals to a x multiplied by x, that is x squared. Again, x multiplied by negative 4, that is negative 4x. Then I said 4 times x, that is positive 4x. Again, I said 4 times negative 4, positive 4 times negative 4, that's going to give us negative 16. So I can now add my like terms. You can see negative 4 and the positive 4 will cancel out. So I have a is equals to x squared minus 16. Now this is what I get now after I substituted my roots. I get y is equals to a x squared minus 16. Now I need to find a in order for me to complete my equation, because I've already discovered what is q. Q is negative 16. But I cannot say this is negative 16 because I need to know first what is a. Now if a is 1, then I can say q is negative 16. But if a is 2, for example, let's say a is negative 2, I'm just making an example. So if a is negative 2, for example, that means that now I still have to multiply by negative 2x squared. Then negative 2 times 16 will be a positive, that is 30, 40, 2 times 16, that will be 36, ne? No, not 36, I think it's 32, yeah. Yeah, for example, it will be 2 times 16, I think it's 32, yeah. So you can see that q now is 32. So if this a is negative 2, you have to multiply now by 2 multiplied by that 16, then you get the correct value of q. So I'm saying to you that you cannot now decide and say q is negative 16 because you don't know the value of a. You need first to find what is the value of a, then you can decide then what is the value of q. So let us now find that a. How to find a now? To find a, remember we have this point that we have not used. The only thing that we used first, we used these roots. We took the first root, we said is x1, we substituted here. We took the second root, which is positive 4, we substituted there. That's the first thing that we did. Now we have to use now the second point, which is 6 and 10. So this 6 is x coordinate, this 10 is a y coordinate. So we have to substitute now these 2 points, that y and that 10, by this point that they gave us, which is x and the y. So we have to use now these 2 points. We're going to substitute y with 10. Then we're going to set a. We will substitute this x now by 6. So we're going to say 6 squared because of this x is squared minus 16. So now we have to go and find a, because a is the only variable that is unknown in this equation. So what is 6 squared? 6 squared I think is 36 minus 16. Now we have to calculate 36 minus 16. 36 minus 16. Okay, we're going to take a 10 here, then we're going to be left with a 26. We're going to take a 6, we'll be left with a 20. So 36 minus 16 is a 20. So that means we have to divide this side by 20, divide that side by 20. So that means a now is equals to 10 goes into 10, 1. 10 goes into 20 2 times. So that means a is equals to 1 over 2. A is equals to 1 over 2. Okay, so we have to go back now to our equation. Remember, we wanted to find this value of a. Now we do know what is a. So we go back now to this equation and said the equation is y is equals to a half, because a is a half, bracket x squared minus 16. So we do know now what is a. We can multiply now everything that is inside the bracket by a. So the final answer now is y is equals to half times x squared. That is a half x squared half times negative 16, that's going to be a negative 8. It's like negative 16 divided by 2. Yeah, that's a negative 8. So now this is the final answer for our equation. So the equation of this graph is y is equals to half x squared minus 8. That is the equation. So that means that now a is positive. As you can see, it's half, and q is negative 8. That means this graph was lowered or shifted down 8 units down. So this turning point, this y-intercept, is actually negative 8. So we know now what is the value of that q. It's negative 8, or it's the turning point is negative 8. So this is how we determine the equation of the graph when you are given two x intercepts and 1 point on the graph. Now we are done with equation example number 2. So now I'm going to example number 3. Now I'm gonna show you now, if they gave you the equation and they said draw the equation. Now, how are you going to be able to draw the graph, the parabolic graph? So we are going to do two examples for the positive graph, and we're going to draw the negative graph. Then we'll be done with our video. Okay, so this is example number 3. So for example number 3 now, they say sketch the following graph showing all intercept with the axis and the turning point. So they want us to sketch the graph, and they want us to show all the intercepts, x-intercept and the y-intercept, and we need also to show the turning point. Now they gave us now the equation. The equation is g of x is equals to negative 2x squared plus 8. So we have to draw now this parabolic graph. Now we can see now a is negative. So we know the shape of the graph is going to be a sad face, or it's going to be a graph that is pointing downwards. They gave us the q. The q is positive 8. That means it is shifted 8 units up. So we need now to draw this graph. So the first thing that you have to do, you have to draw the Cartesian plane. Just draw the Cartesian plane. Okay, so this is just a sketch. So I know on my left I have positive x-axis, on my right I have positive x-axis, on my left I have negative x-axis. Now up here I have positive y-axis, down here I have negative y-axis. So I need now to use this Cartesian plane to plot my graph. So the first thing that I have to go and find here, I'm going to find my x-intercepts, the points where the graph will cut the x-axis. So we can easily find that one. The formula is g of x is equals to negative 2x squared plus 8. This is the equation that they gave us. So to find now the x-intercept, we know that we have to let y be 0. When y is 0, that means that we have negative 2x squared plus 8. So we're going to find now the x, because of x is the only variable in this equation. So let me put this on the right hand side. So I took that negative 2x squared, I put it on the right hand side, so it's going to be a positive. Then I left the 8 on the right hand side. So you took the negative 2x squared from the right to the left, it's going to be positive. Then the 8 remains positive on the right. So now I'm going to find this x. So the first thing that I have to do is to divide now by these 2. And what I did on the left, I do it on the right. So I have x squared now remaining on the left is equals to a 4. Now I can find now x by saying square both sides. So if I squared both sides, or let me do it this way, because I have to find 2 roots here. If you take this 4 to the left, you're going to have x squared minus 4 is equals to a 0. Now I can now factorize this to become x times x. Now to find the factors of 4 will be a 2 and a 2. That means the other 2 must be positive, the other 2 must be negative, because I don't have the middle term here. So now I have 2, negative 2 times positive 2, that will give me a negative 4. So that means here x is equals to a 2 or x is equals to a negative 2. So now I do have my two roots for x. It's a positive 2 and a negative 2. Alternatively, you can say, if you want here, if this x squared is equal to a 4, you can just take that root now to the right. It's going to have plus minus the root of 4. So you can say now x is equal to the positive root of 4 is 2 and the negative root of 4 is negative 2. So you can also do it this way. It's much shorter this way. Otherwise, you can also do it the longer way if you want. Yeah, here is it. So you can do it this way by just take the square root to the other side, set the square plus minus square root of 4. It's going to give you a positive 2 or a negative 2. Or you can just factorize this x squared minus 4 to be x minus 2 and x plus 2. Then x is equal to 2 or x is equal to negative 2. Now let's plot now these 2 points. This is x. This is x. This is x equals to 2. Let's say this is 1. Then this is 2. So let's say, okay, that's negative 1. That's negative 2. Let's say this is positive 1. Let's say this is positive 2. So I'm looking now for the x equals to 2. This is x equals to 2. It is this point. I'm going to make it bigger. Now I'm looking for the point where x is equals to negative 2. This point is a point where x is equals to negative 2. I'm going to make a bigger dot there. So I do have my two roots. Now I need to find my turning point, my y-intercept. I already know my y-intercept is 8. So I'm going to say, where is 8? So let's say this is 1, 2, 3, 4. Okay, I won't have space. Let me just use 2. Ne? So let me just use 2. Let's say this is 2, 4, 6, 8. So here is 8. So I do have my turning point. I'm going to make it bigger also. So this is my turning point. These are my two roots. So if you do have a turning point and you have your two roots, then you can plot your graph. You just have to join all these 3 points into a curve that points downwards. So I'm going to do that now. Yeah, here is my graph. So I have a sad face. I have a parabola that is pointing downwards with a turning point of 8 and my two roots, which is negative 2 and positive 2. So this is how you plot a graph if you are given the equation. So we are done now with plotting the graph that is negative. So we're going to go now and check for the graph that is a positive one, a smiling face one. Then that would be the last example. Yeah, this is our last example. So they say here, sketch the following graph showing all the intercept with the axis and the turning point. So you are given now this equation, f of x is equals to 2x squared plus 2. So we are required to plot now this function or quadratic function. So the first thing you have to do, just do a sketch of a Cartesian plane. So let me do that. Okay, so now let's go and make our calculations. So we are given f of x is equals to 2x squared plus 2. So let's first find the x roots. So we know that we have to make y 0 or make this f of x 0. Let me not say y all the time. So just make this f of x 0. So that means that we have 0 is equals to 2x squared plus 2. Now we're going to take now this 2 to the other side. So I'm going to have 2x squared is equals to negative 2. So I took that 2 that was on the right, I took it to the left, so it became negative. So let me divide by 2 on the left, let me divide by 2 on the right. So I'm going to have now x squared is equals to negative 1. So you know when you are here, you have to take the square root. So you can say, okay, before we take the square root, let's try to factorize and see if it can factorize. So if I have x squared, I take the 1 to the left, it's going to be positive, equals to a 0. Now let's check if we can factorize this. Let's check if we can factorize this. 1 and a 1. So it cannot factorize because a negative 1 times a positive 1, it will be a negative 1. Or if you said x is negative 1 and x is negative 1, so negative 1 will give you a positive 1, but negative 1 times negative 1 will give you a negative 2. That means that we don't have a middle term here. So that means that starting from here to here, this is impossible. We cannot now find the root of this. You cannot find the root of a negative value, a negative number. In other words, that means here there are no solutions. So there are no solutions for x in this equation. So there are no solutions for x. That means that the graph does not cut the x-axis. So that's what it means. There are no solutions for x. So what now we know q is the 2. And we know that a is a positive value because of it is 2. So that means this is a smiling graph. This is a smiling graph. Yeah, it's a smiling graph and it is lifted how many units? It is lifted 2 units up. So this is 2. This point here, the turning point is 2 because of it is lifted 2 units up, and it is positive because a is a positive value. But there are no x-intercept. This graph does not cut the x-axis. That's why we could not find any x-intercept there. So that means this is how the graph looks like. It's the graph that has been lifted from 0 to 2 units up, and there are no x-intercept. It does not cut the x-axis. Yeah, so this is how you'll draw the graph if you are given an equation like this. So I think now we are done with the video on the parabola. So the next video now will be on the hyperbolic graphs. Then the third one will be on the exponential graph. Then after that we'll do exam questions. Okay, now I'll see you on the next video.